I think it's safe to say that our next speaker is deeply engaged and committed in bringing fundamental research results into both value creation by innovations and entrepreneurships. Dr. Asgeir Sørensen is a professor in marine control system at the Department of Marine Technology at NTNU in Trondheim. Sørensen has a PhD degree in engineering cybernetics at NTNU and has been employed at Marine Tech, Sintef, and in various positions in the ABB group. He was the co-founder of the company Marine Cybernetics and has also co-founded 3 other NTNU spin-off companies. Since 1999, Sørensen has held the position of professor and was in the period 2003 to 2012 key scientist in the Center of Ships and Ocean Structures, and currently he is the acting key scientist and the director of the Center of Autonomous Marine Operations and Systems. He has also, together with colleagues, established a marine cybernetics laboratory in the Applied Underwater Robotics Laboratory at NTNU. Asgeir will be talking to us about step change in ocean and Arctic research capabilities using autonomous marine robots. This will be exciting.
Thank you, and good morning. Just very short, I'd like to present AMOS. We are a center of excellence funded by the Norwegian Research Council, and we also have a partnership with Equinor and Sintef and the DNV-GL. And as you see, this is a 10-year research program, and that in itself is actually also an important tool to create impact. And you see we have quite a lot of professors involved, and we are annually educating about 100 masters in these fields. And there is also 88, or I think close to 100 actually at this time graduated PhDs. So this is a huge program, and we have also been adding up with additional funding. We have 3 projects that is on technology for mapping and monitoring of the oceans, including ARCT. That is what I will speak about today. But we also work more specific on some of the marine robotic platforms. And a part of that could also actually be autonomous ships. And then we are also into more classical ships and ocean structures. That could be oil and gas installations, it could be fishery, aquaculture, offshore wind. So we have a quite broad activity within the blue economy. But moving into autonomy and this technology for mapping and monitoring, drivers for autonomous systems is actually aerospace. We also see that increasingly also in automotive industries and also in robotics, but also marine robotics is a driver for autonomy. And what is autonomy? That is actually to have a more intelligent control system if you compare it to classical control. Very often also autonomy is related to unmanned systems, but unmanned systems can be remotely controlled, meaning that they are not particularly intelligent. So the way to increase intelligence is actually also very critical in this. But we have already worked with this, I would say, type of technology in years in advanced ships and offshore installations as well. And that has led into autonomous ships. So autonomy is I would say, it's a new enabler, which actually will create new possibilities. But then I just jump into this diagram. And the point here is not to bring you to all boxes, but to underline or to stress the importance of interdisciplinary. Because I'm you could say, a marine technology guy. I know my environment. I know the surroundings these assets are going to operate in. That is important. That is physics. Then I know how to control them. But then we also need to, you could say, a scientist. I'm working also with marine biologists. They are not particularly impressed that I'm running a robot. They are interested in data. So in that sense, we also have this payload data. And the question is, can we automate the scientists more and to bring this knowledge in how you are classifying the findings and also to analyze that in the robot and then replan the robot on the fly. And of course, there's a lot of other aspects about risk and reward, what about collisions, etc. And if you put that into other broader contexts, we are also into ethics as well. NTNU, we have been very lucky also to cooperate, obviously, very extensively with UIT here in Tromsø. So we have together also built up a huge infrastructure. So we are now also starting with small sats, and we are going to launch numbers of these small sats from NTNU, but we also have 20, 30 drones we also have, and then on the sea surface we have our own ship, but also unmanned ships. And there is an explosion in these sailing drones, and which in a way can give you completely new capabilities, but still we need a ship. Manned ship where we could actually support operations. And going underwater, we have also numbers of remotely operated vehicles, but also autonomous vehicles. So what you could see here is a huge technology, I would say, room, and it's exciting for a technology guy like me. But then you could say, for what purpose going into mapping and monitoring? So what you see here is you have a time scale. We are going to investigate dynamics in the temporal scale, but we are also going to covering spatial scales. Sometimes we are interested into details with an extremely high resolution, and if you're going to have something with high resolution, you better stand still, which I, time to time, have problem with, too much energy. But sometimes you need to move around, and you are going to capture bigger areas. So the point here is, how do we work with these robots? So you see also landers are fantastic in order to be on the correct place, but the question is, should I only be on that place, or should I have bigger capabilities? So then you see how it adds up with these robots. And this becomes quite messy. And the question is, again, what do we really measure? So here we are also struggling about methodology when we are going to compare data with data. What did I really see? Probably it's only the seafloor that is not moving. So else there is a huge dynamics. And we are also working with what we call the information pyramid, and we also call it game of drones. And the point is that you start with satellites, remote sensing. They give you one overview, and then you could start to work with these drones in the air. And then they are again working with the ships, and unmanned ships, and underwater. So this is a huge operation that takes place. And you may, this is also an interesting, I would say, I may call it here fun fact. You could start to think, who has been the driver behind these heterogeneous systems of networks? You may think it's the environmental agencies, researchers. No, it's actually the oil industry in Norway. It's Equinor that has been pushing this as a methodology in order to have better control of the oil and gas operations. So what we have done together with Equinor and SINTEF and other partners is also to put this into science use in full. So that is also important to be aware of. So here you see an example where we are going to work with also for aquaculture. This is algas, which can destroy fish, and this was on the table now in this region here in last year, and you see how this remote sensing using satellites in a way could see the gradients, and then you could go down and start to inspect this closer with drones and also taking samples with the surface vehicles. So the first satellite we are going to launch is this with the hyperspectral imaging, which will give you unique capabilities in order to look into the ocean color. And here we are also working together with a lot of other partners in order to get this a reality, including NASA. So what we are aiming to is actually what we call digitalization of the ocean. So when we started almost, it's 7 years ago, we said that we should, in a way, move commas. We should to make a paradigm shift. We should be able to gather 10 times more data at a cost of 1/10. And the reality is that we are not gathering 10 times. We are gathering 1,000 and millions times more data compared to what we did 7 years ago. So it's really a paradigm shift. So in order to, and then we are using all these assets to to do this. And then you could start to question, okay, that was good, but what about the time lag regarding analyzing the data? How should we share data? And then we have a new challenge in our hand, and that is big data and big data analytics. So here you see an example of where we are also cooperating with RevOcean regarding ocean data platform, where we actually could share data. There is also numbers of national and international setups of sharing data. So this is crucial also to get this understanding. Finally, I will show you some examples of campaigns we are doing. Here you see pictures of my colleagues from Tromsø and NTNU. It was a campaign in January this year, and they just came back a week ago. This is Jørgen and Geir and Malin, and the guy on the left, I don't know. But to the right, we have a group where we have one of my PhDs, and unfortunately I was not able to join. I should do that, but you see there a robot where we are putting two small robots which are carrying then a hyperspectral imaging. And the cost to do this is very low. It's feasible, and this is giving completely new insight in marine life under ice and on the seabed, where we are operating this from small boats close to Helmer Hansen, and building up completely new knowledge about algas and if they are growing or if how the welfare, I would say, are during the polar night. So this research will be published quite soon by Geir and Jørgen and that team. So that is one example. It is impossible to access this without robots. Another example where I was happy to be a part of, that was a campaign we did in Svalbard in June. We were looking for marine archaeology and also seabed mapping in the northern part of Svalbard. And we have in Norway had an oil age before, so the Arctic whaling in this period from 1600 and further out was also a huge industry to harvest oil from whales, which was important for European economy. And of course, there was a lot of interest and also a lot of conflicts between the big players there. So there are numbers of wrecks there. And one of what we hoped is that these wrecks should be able to sustain and be more preserved in this cold water. So that was, we were looking for them. And so here you see the northern part of Svalbard. We were on Smerenburg in this area and looking for, to be honest, on wrecks. And we hope to see, we also, sometimes you hope to see what we call a Donald Duck wreck. But we didn't find any. And one reason was actually that the warm water coming up from the Atlantic is in a way destroying that. So here you see survey areas where we used AUVs, and we made a lot of targets. So we are going to investigate, and typically you work with AUVs to have a broader coverage, and then you go with remotely operated vehicles to check and to test them out. And here you even see the rector of UIT participating. So we joined into an outreach campaign. So it was not only for fun, but also even the rector needed to do hard work, and she did well. Anna is simply great. And she enjoyed it. And of course, there's tremendous experience to be out in this environment. But the challenge here, meaning that we are in hurry, also concerning cultural heritage, is that these shipworms are in a way are eating them up. And we are wondering what is happening if you're going further east. And we have some knowledge that in Canada, they don't have this problem yet. But I think this is also a part of our history, and we need to look into that as well. Finally, I will say that we, together with Tromsø and NTNU, we have, headed by Jørgen, there is also coming out a new textbook called Polar Night Marine Ecology. And this will be launched this winter. And to the right, you see I have been writing one chapter with other colleagues where we are going through all these different platforms, looking into their characteristics, their benefits, and also different sensors, and trying to make a holistic view on this. So that was yeah, just go and buy it. Run and buy. Thank you very much.